Now, when you guys went last year, I believe you might have seen this happen. Don't worry, no, it's done. I got it. I got you. There you go. I believe you actually did this. So today's lesson is kind of reviewing what you did last year, just reminding you that you could use this technique if you wish to solve ratio problems. What we're going to do is we've been talking about ratios, and we're going to use these word problems that I give you, and we're going to actually put a picture to them. We're going to draw pictures. And I believe you've done this. I believe you went to the lab and did something called thinking blocks. These are the handwritten ones. All right, so I'm just taking today to refresh your memory that it's possible if you need to. Making a diagram and a picture of a word problem sometimes helps us solve and make sense of it. So that's all I'm doing today. It doesn't mean you have to do this, but back here on my back wall I have the actual poster that goes along with this method. This actually came from what's called Singapore math. The good island of Singapore, country of Singapore, actually is one of the top countries in our nation for obviously academics and math. This is where this modeling came from. Okay, Singapore is way up there, with Japan, China. When you look at national achievements. So basically, these are the 7 steps that I'm going to take you through. I don't know if your teachers last year stressed these steps, but I think that if you look at these, I hope that you might remember them. Okay. So what we're going to do is we're going to look at the first problem. You have notes, which I hope that you find. And make sure that you match, it's Mr. Romeo. Make sure you have the note sheet that says, the first problem says Mr. Romeo. And if you look at it, there's actually an R. You see the R1 at the bottom corner? Yes. That actually corresponds, that example actually corresponds with the other worksheet, Ratio Modeling Day 1, for homework. So like the little codes at the bottom of your note sheets, the R1s and R2s actually correspond with your homework Day 1, Day 2, Day 3, and Day 4. Does that make sense?
So tomorrow will be R2.
It depends on how long it takes us today. I only did this for a day, but if it does take us 2 days, I might do that. All right, we'll see how it goes. That's all I'm saying. We're going to see how... Yeah, Lauren, what are you doing? What do we got? You got something more? All right, I'll put this over here, Lauren, for you. Now, what we're going to do is the first one, you're going to model exactly what I do first. We're going to walk through the steps here. There's a glare over here, so I'm probably better off to put it back over by Nick, huh? There's not a glare for you guys? Okay. So, first of all, read the entire problem. Obviously, we need to read the entire problem. Some kids in my classes have used highlighters to highlight the most important things. You don't necessarily have to do that. But in this case, it says, in Mr. Romeo's auto shop class, the ratio of boys to girls is 5 to 2. If there are 35 students in the class, how many are boys? So what we're going to do is you might be able to solve that. You might be able to solve that by in your head. But what we're going to do is, what I want you to practice is actually drawing a picture of it and using bar models with that. So you might have done it. I'm just reviewing it for you, okay? So the nice thing about this is where I want to make sure you understand is once you have a problem like this, what if I wanted, instead of finding boys, what if I wanted you to tell me the ratio of boys to the total of kids in the class? The ratio. So like, what I want you guys to be able to do is take a problem like this, and okay, yeah, you can solve it. We can put a model. We can draw a model of it. We can find out how many boys are. But using the model, could you go one step further? Okay, and that's where obviously the 7th grade level goes. 6th grade is just modeling it and solving the exact. So like now instead of boys, I want to know how many are girls. What's the ratio of girls to the total kids in class? And so forth. Okay, so we're going to kind of milk it a little bit. We're going to kind of bring it to that next level. So that what you did last year was just you put the model in it. Now this year we're going to take it one step further. All right. So here we're going to rewrite the question in sentence form. And what we're going to do that is in the bottom of our sheet. So looking at the question, how could we restate that so it makes us focus on what we're trying to find? How could we rewrite the question, Garrett?
Mr. Romero's auto shop class has blank boys.
Yeah, you also can shorten that up. Mr. Roberto's class has blank boys, or there are blank boys in the class. You can make it very generic if you want, because what that statement is telling you is focus in on that. That's what you're trying to find. I always like to know where I'm going. Okay? Especially in a math class or a word problem, I want to know what I'm trying to find and stay focused on that. Okay? If you get distracted, a lot of times what happens is you get lost in the shuffle. All right? And you get confused. All right, so I'm just going to put, if you don't mind, there are blank and then boys in the class. There are blank boys in the class. Whoa! What happened there?
What are you doing?
I'm trying to move my sentence back. It kind of moved on me.
You're like zooming out.
Huh?
You're zooming out.
I know. I see it. Don't worry. Don't worry. Be happy now. All right. Here we go. So, the first thing that you're going to do is, remember, what does a ratio do? What's the definition of a ratio? JP?
It's like a fraction.
True. But what does it do?
It compares one thing to another.
Okay, so it compares two different things. What are the two things are we comparing in this problem? Bailey? All right, so this is what you're going to do. Take your straight edge. I can't use a straight edge up here, otherwise I'll miss my beat here. So what you're going to do is you're going to take your straight edge, your ID, or your ruler, and draw a straight line. That's going to be like that's where your bars are going to start. That's your starting point, okay? Now what you're going to do is you're going to put boys, and then you're going to put the other thing that we're comparing, which is girls. Sorry, it didn't write. Now, which of these two has the larger? Who has more in the class? We have more boys in this class or girls in this class? Boys. So we're going to draw that bar first. And if you notice, we have 5 to 2. So what we're going to do is we're going to draw a bar, and we're going to make sure that it represents 5. Okay? If you want to, you can. Now, I don't know about you, if your teacher, if you remember this last year, what I tell kids is, isn't 5 an odd number?
Yeah.
Yes.
All right? And making this bar, because it does take a little bit of time to get used to. What I do is when I have an odd number, I take part the end, and I just draw a little line here. And now this part, that's left, I have 4, right? Blocks left. So I go halvesy, halvesy, halvesy. So I go halvesy, here, half there, and then there it's 5 sections. Okay? So take a little part off the end, and now you're back to an even number, right? Don't you have 4 left to go, 4 parts to go? So then you can go half, half, half. Halvesy, halvesy, these are the halves. And then it's 4. Okay? Huh?
That's not confusing.
No. Now the girls, how many sections do the girls have?
2.
2. Now, guess what? You're going to use this bar to help you model the girls. Look up here. What I would do is, see how there's 2 here? I would take my straight edge over to the 2 here, and then draw a line. And then draw a line here, and draw a line there. And now draw that. Because the thing is these 2 blocks here need a model 2 up here as well. They have to have equal representation as close as you can. Otherwise your picture doesn't look like. So what I would do is measure over 2 how much your 2 blocks upstairs. Very good. You see what I'm saying? So like the 2 and the girls, doesn't these 2 look like 2 that could be up here? So they're all equal representation. Because all of these blocks actually equal the same number. So you kind of want them to be equal spacing in between them. Now, what do boys and girls? What else do we know? Do you guys see 5 to 2? You see the ratio now? Picture? All right. What do we know about that 5 to 2 in that class? Bree?
There are 35 students in all.
And students include what?
Boys and girls.
Boys and girls. Now, I don't know how I don't know if you guys, I don't like this thing. What I do is I just take and just use that kind of, hey, if I group both of these boys and girls together, I'd get 35 total students. What'd you do, Sam? Oh, did you do something? My screen? Are you blowing on it, or what are you doing? What's going on? All right, now, what we have to do is we have to figure out how many boys are in the class. Anybody have suggestions? Anybody see something we can do with what we have represented here? Any calculations and this is where once you start doing your calculations, I'll show you how to demonstrate that. Anna, have an idea.
Divide 35 into 5 parts.
No, if you just take 35 and divide it by 5, You're telling me that there's only boys in the class. What did Bree say? Students include what?
Boys and girls.
So how many groups do we, we have 5 sections for boys. How many girls do we have?
2. 7. Divided by 35.
Ah, does that make sense? We're going to take all those, don't we have 7 parts right here? Total? Okay? We're going to take those 7 parts and divide them by, and we're going to take that 35 total and divide them into 7 parts equally. So what you're going to do over here, underneath, you're going to take a number 1. That's our first calculation. We're going to take 35 and divide it by 7, and that's equal to 5. Okay? So now, what you're going to do is you're now going to put each of these little boxes here that represents the girls and the boys actually equal 5 students. They represent 5 students in the class. Nick?
Well, the ones right under that block is 5.
No. Nope. Now, what would be the calculation? Now, obviously, you could probably do this in your head, but we're going to write this down so we know. What would be the calculation to get to boys? What could we use now? Meg?
5 times 5.
There you go. And how many boys are in the class then? Now, one thing that Mrs. Alms did not do, that I forgot to model for you guys, because that's horrible of me to do that. I did not model. That's not proper teaching technique. Is, what are we trying to find? Boys, correct? I forgot, before we started doing all this calculation, is I always put a question mark what we're trying to find. Okay? We're trying to find boys. Do we care about the girls at this point? No. Could we find the girls, though? Could. Yes. How many girls are there?
10.
10. Could we make a ratio of boys to total? What would that be? 25 to 35, or could we just do 5 to 7? Reduced? Could we do girls to total? You see how we can extend this. We don't just have to stop with boys. We can find a lot more than just boys in this problem. Okay? Based on this, you know, we could predict another situation. You see where this could go? We could start predicting with this. Okay? If there's 25 boys in this class, how many boys in the next 2 classes of auto shop? Okay, total. You see what I'm saying? Like, you could use things. Do you guys believe that people use ratios or things to help predict? Okay? If we have a trend, think about stocks. If our stock has a trend of, you know, so many dollars per month, couldn't they predict the next 6 months' profit? And we use ratios or rates to do that. Okay? So that's what I'm talking about. So, we're going to take this, and she said 5 times 5 is equal to 25. And now, we're not done. The last step is to write the answer in the sentence and make sure the answer makes sense. So what do we have to do? What are we going to put right here? 25. There are 25 boys in the class. Does that make sense? Or Mr. Ramiro's auto shop class has 25 boys. Good?
I know an auto shop.
It says auto shop class.
Oh.
Did you overlook that? Yeah. Sometimes I do that too. I read quick and I skip words. Then you don't know what's going on. You guys good with that? Can we skip to day 2? Do you think we need to do another day 1, or do you think day 2? We can go to day 2? Okay, let's go to day 2. So let's flip that paper. Obviously, I have those, so I'm going to go to, is it ratio of sunny days to cloudy days?
Wow, that laws do Colorado.
Now think about where we're at. Obviously we're in Colorado, so I don't know if you guys know the climate there. So, would someone like to share how are we going to restate the question? So read the problem to yourself, and how would we restate the question as a statement? Harrison, what do you got?
There are blank cloudy days in Mossville.
Yep. There are blank, cloudy. Are you serious? I'm going to stop there, but you can add in Colorado or in Lawville, okay? Mine keeps on moving. Again, I want you guys to start with your barrier. Draw your straight edge. And what are we comparing in Colorado, Lawville? Cloudy to sunny. Two different things. Can we measure both of those things?
Yeah.
Sure we can. All right. What if we did that in Seattle?
Oh, is it cloudy?
Rainy. Yeah. Very. They say that it's very depressing to live there, unless you like rain, obviously. So what comes first in our ratio? We're doing sunny. The sun will come out tomorrow. Right? Right? I've been watching Annie like every.
Right when you said it, the sun just came out. It got brighter in here.
Thank you. See?
Oh, yeah.
It actually got brighter.
Like really, it actually did.
See? Just a little song. Cheer everyone up.
No, like it got brighter in here. Like
It's like an orange juice commercial.
No, it's Annie.
No, there's a
Hey, you know what?
commercial that has that.
The sun will come out, and when Annie says the sun will come out, it'll come out.
There's a
Okay.
commercial for
So,
orange juice.
sunny days to cloudy days. Sunny days. How many parts does sunny days represent? 9. So, obviously, our bar is going to be a little bit bigger than our 5, right? Otherwise, I mean, to make it equal. So, what I would do is, make it a little bit bigger than, obviously, your other one. And again, 9 is odd. So, if you guys want to watch up here, I'll make it a little bit easier for you. One thing that I do is I chop it off. Now, this section from here to here, I have to make 8. Think about it. 8 is even. Half. Do you see? So if you can get your bar down to an even number to break it into, then it's a little bit easier to make it look a little bit better. And then you do your 4s into halves.
Yeah, you have 9.
Now I have 9. And then obviously cloudy days, again, are 2 parts. Remember, go over 2 parts from the sunny, bring your obviously your ID down or your straight edge down, and draw the part there, and then cut that also in half. And my orientation must be off, because look at how I stop and it's down there, so I'll fix that. So in a given time period, if there's 108 sunny days, how many cloudy days are there? So what are we trying to find? All right, so we're going to put our question mark right here, because that's what we're trying to find. 108, what does that represent? What is that? 108 what, Nick?
Sunny days.
Sunny days. So this bar right here represents how many days?
Sunny days.
Sunny days. Now this time, we don't know the total number of days, do we? We don't know the total number of sunny and cloudy days we're talking about, correct? Okay, so they don't give us the total this time. They give us a part, which is, the part is the cloudy day part of the ratio. So how could we use that to help us fill in the box? How could that help us, Richard? What could we do? By, so we're going to take that 108 days and divide it evenly amongst the 9 parts that we have for sunny. You all get what Richard's saying? So we can take, because isn't it 108 and have to be evenly distributed to each of these 9 parts. So our first calculation is 108 divided by 9, which is, guys, 12. So if these are all 12,
Those must be 12.
what are these down here? What are the? They're 12. So what's the final calculation to figure out our question?
12 times 9.
12 times what? 2 is what?
24.
4, and our last thing is? Fill it in. So how about this? How about we do day 3 and 4 tomorrow?
Okay.
We do know.
Is that good?
Nice.
So then what we'll do tonight is this. We'll do 4 problems. In our assessment packet, day 1 and day 2 problems. Did you guys see how you have 2 problems for day 1 and 2 problems for day 2? So if you would, model those 4 problems, just those 4, the first 4. And then tomorrow we'll do day 3, right? Is that right?
There's no day 2. There's no day 2. It's
There's only
day
day
1 and then day 3.
So we do
What
one
happens
for
in
day
day
2. We decided not to print it out, so we're doing day 1 tonight. What is that question? No more day 2.
Well, that's
Day
silly.
1. Day 1. Day 1.
Well, that means you gotta do 6 problems tomorrow.
Okay.
Why?
But then you gotta do, because I want you to practice day 2.
What about the quiz?
Alright, let's do this.
Stop being lazy. Let me just do day 1 and day 3.
Hang on.
Wait, why don't we just do
Hang on. Would you guys chill out? No, we don't.
What if he doesn't know?
Sam.
Then we have to bring up the whole paper.
It's not fair. Yours is bigger than mine.
Alright, I'd like you guys to try, please, for in the quiz section, do quiz number 1 and number 2, because those two are
Quiz number.
1 and number 2, and then day 1. So day 1, and then quiz, and then I'll split the problems up. For instance, day 2 just disappeared. I'll have to figure that out. Quiz, the quiz section, you guys see the quiz section? Do number 1 and number 2 on that one, and then do just day 1 assessment problems.
Okay.
Everyone got it?
Yeah.
Alright.
I bet
Everyone sure?
one problem.
Now use your straight edge for your, your starting blocks to make it nice. Okay? Come on.